Imagine a vending machine stocked with all sorts of snacks. You want a chocolate bar, you press the button and out it falls. Simple, right? Now imagine pressing a different button, maybe one labeled salty. A bag of chips tumbles down, same machine, different input, different outcome. Math is similar. It's a system with amazing potential. But the answers we get depend entirely on the questions we feed in. We choose which buttons to press. We shape the problem, and in doing so, we shape the solution. This isn't to say math is random. The vending machine has rules too. Pressing chocolate won't give you an apple. But within those rules, there's incredible flexibility. Understanding this flexibility is the key to unlocking the true power of mathematics. We often think of math as dealing in absolutes. 2 plus 2 always equals 4. But even these seemingly unshakable truths depend on the context, the world we're operating within. Take the square root of 4. Most people will say the answer is 2, and they're right, in the realm of positive numbers. But there's another answer, -2. Both are valid, depending on whether we're considering all integers or just positive ones. The truth didn't change, but our perspective on it did. This happens all the time in math. What seems like a universal truth in one system might be just one possibility among many in another. Even something as fundamental as geometry, the study of shapes and spaces, can be viewed through different lenses. We're most familiar with Euclidean geometry, the kind we learn in school, where parallel lines never meet. But what if they did? That's the basis of non-Euclidean geometries, where space itself can be curved. Imagine drawing a triangle on the surface of a sphere. The angles won't add up to 180 degrees. This isn't to say one geometry is right and the other wrong. They're different systems, each with its own rules and applications. Just like our vending machine, the output changes based on the framework we're working within. Section 4. Clockwork Math Adventures in Modulo. Let's look at a system called modular arithmetic. It's like clock math. Imagine it's 10 o'clock. What time will it be in 5 hours? Easy, 3 o'clock. We don't say 15 o'clock because on a clock we cycle back around after 12. This is modulo 12 arithmetic. In this system, 15 is equivalent to 3. Similarly, 9 plus 5 would equal 2, because we wrap around the clock face. Modular arithmetic might seem strange at first, but it has real-world applications, particularly in cryptography and computer science. It highlights the flexibility of math. By changing the rules, we open up entirely new possibilities. Section 5. The language of what if. Math isn't just about finding the right answer. It's about asking what if. What if we change this assumption? What if we explore this new system? What if we look at the problem from a different angle? This is the true power of mathematics. It's a language of possibility spaces. It allows us to model different scenarios, explore hypothetical situations, and understand the consequences of changing the rules of the game. By asking the right questions, we can unlock these possibilities and gain a deeper understanding of the world around us. Section 6. Unlocking new possibilities. The next time you encounter a math problem, don't just focus on finding the answer. Think about the question itself. What assumptions are being made? What are the underlying rules? Could you change the question slightly and discover something new? Could you imagine a different set of rules and explore the consequences? By embracing the flexibility of mathematics and the power of asking the right questions, we can unlock a universe of possibilities and see the world in a whole new light.